After finishing the brain pop video, reflect on what you learned and list 3 to 5 forms of energy below. You can see there are 5 numbers, but you only need to list 3. If you can, try to list 5 from the video, and feel free to go back to look at the video again briefly to fill in the different types of energy.
Potential energy. Potential energy is energy that is due to the position or condition of an object. Some examples of potential energy are a roller coaster car at the highest point has a lot more potential energy than the roller coaster car at the lower point. A dam holding back water has a lot of potential energy. Apples on a tree in relation to the ground have potential energy. A bow that is being pulled back has potential energy to fire that arrow. And in the same way, a slingshot that is being pulled back has potential energy.
By contrast, kinetic energy is the energy of motion. So that's when you have something moving, such as a moving car, a person walking, a ball moving after it's been kicked. Below in the bottom left, you see Newton's cradle demonstrating kinetic energy. You can see the first ball swinging, the swinging motion, that is kinetic energy. A flying bird is kinetic energy. And then that same illustration from the previous slide, a roller coaster, but this time, if you see the pink roller coaster down at the bottom, it's totally changed from potential to kinetic.
Here's another illustration demonstrating potential and kinetic energy as well as mechanical energy. So the hammer has potential energy as it's in place above the nail. When the hammer starts moving down, kinetic energy is being used. And then when the hammer impacts the nail and starts doing work, we call that mechanical energy. In the bottom picture, we see potential energy as the archer pulls the bowstring back. When the archer releases the bowstring and the arrow flies forward, the arrow is using kinetic energy.
So you can see, as is also illustrated in this picture, that there is a link between potential and kinetic energy. They are inextricably combined together. So here at the bottom, you see the boy riding up the hill on his bike. He has kinetic energy. Obviously, it's becoming less and less as he gets to the top because it takes more effort. But as he gets to the very top and he's poised on the hill and not moving, he has a ton of potential energy. And then as he's starting to go down the hill, his kinetic energy increases. So actually, there's a balance of potential and kinetic as he moves throughout the hill, and the relationship or ratio between the two changes as he starts from the bottom, goes to the top, and then gets down to the bottom again on the other side.
So now you're going to watch the next video clip that looks like this, and then you'll come back to the next video where we're giving you more information.